After a large rock is dropped into a lake, the ripples radiate outwards. The crest of each wave is 60% of the height of the one before it. And the first height is 4 inches. What is the height of the 10th ripple? Knowing that the first one is 4 and that each one after that is 60% of the height. So it's good just to write down what we know. So we know that our first term, T1, is how high this thing is. That is 4. Now the interesting thing is the R. So what is the ratio? What are we multiplying by? So if where there's a percentage of something, so here it's 60%, so it's getting smaller. So if it's getting smaller, it's going to be less than 1. So it's got to be less than 1. And it has to be 60%. In that case, it's just 0.6. It's like 6 out of 10, or 60 out of 100, or 6 out of 10. So we'll go 0.6. We could, if we wanted to, list them all out and then when we go here, we'll times by 0.6 and times by 0.6. But we have a formula here that gets us right to the end. So let's do n. So our n here is the number of terms, and it wants us to do the 10th term. Let's start by writing the formula. Tn is equal to the first term times r to the n minus 1. So I'm finding T10 here. My first term is 4 times 0.6 to the power of 10 minus 1, or 9. So we'll go 4 times 0.6 to the 9. So for that, we're going to need a calculator. So I'll just use this one, 0.6, and there's usually this x to the y button. So that's what we're going to do, 0.6 to the 9, which is all of that, and then we'll times that by 4. So 0.100777696, and then we can take the number and we can just times that by 4. And so we are at, let me just make this let's just try to write this one down. Okay, so 0.040310, like look at all this. So that equals approximately 0.04 inches tall. So way less, like really, really small. So the 10th ripple, T10, is 0.04 inches tall. Okay, so let's take a look here at the next question. So a ball is dropped from a height of 200 meters and it bounces. Oh, after each bounce, it rises to a height of 80% of the previous height. What is the height of the ball when it has that fourth bounce? Okay. So I guess what's our first term? So we start at 200. Okay, so we're starting at 200. And then our ratio, our R here is 80%. So it's going to be less than 1 because we're not getting larger, we're getting smaller. So it's going to be 0.8. And then you would think, okay, n equals the fourth because we're looking for the fourth bounce. However, sometimes it's actually good to write this stuff down. So we're at 200. Okay. And then we've got our first bounce, the height of the first bounce. And then we have our second bounce. Third, fourth. So here we are with our fourth bounce. Now what actually is that? Well, this is T1, T2, T3, T4, and T5. So in this case, we are not finding the fourth term. We are finding the fourth bounce, but the first term isn't a bounce. The first term is just the normal height. We don't start bouncing till the second term. So our n is actually going to be 5, and that's going to be really important. Now there's a different way to do this. You could start yours here. You could make this your T1, So we go 200 times 0.8 and make this your very first term. So some places do this. 200 times 0.8 is 160. So this is 160. We'll call that T1, and then that's my first one, and then from there we can do n equals 4. But that's not what I'm doing. This is just my initial height. That's T1. If I'm doing my fourth bounce, that is T5. Okay, so now I can actually do this. Tn is equal to T1 times r to the n minus 1. So I'm finding T5 here, which is not the fifth bounce, it's actually the fourth bounce. The height of 200 times my r, which is 0.8 to the power of what? 5 minus 1, which is 4. Okay, so T5 is equal to 200 times 0.8 to the 4. So we have to do that part first. So 0.8 to the power, 0.8 to the power of 4, 0.4096. So 200 times 0.4096. Then I can times that by 200. 81.92. So what is the height? 81.92 meters. Wow, this is a crazy ball. So the height of the fourth bounce is 81.92 meters. So what is the height of the ball on the eighth bounce? So same thing here. Our first term, T1, is 200. Our ratio here is 0.8. And then my n is equal to the number of terms. If I'm looking for the eighth bounce, I'm looking at term number 9. So, yep, T9. So Tn is equal to T1 times r to the n minus 1. So I'm finding T9 here, which is 200 times 0.8 to the 9 minus 1, which is going to be 8. So this is 200 times 0.8 to the 8. So I should probably do that now. 0.8, 0.8 to the 8, 0.16777. $16.777, 216. And I can times that by 200, which I don't know what that gets me, so I'll times that by 200. 33.5544. And then 32 maybe? Yeah. So, I mean, we can kind of round this here. 33.6. I don't know what decimal place to use. Meters. That's how high my eighth bounce is, my ninth term. Okay. So these are a couple questions. What's maybe a little more complicated about this, just setting it up in terms of your bounce. Your eighth bounce doesn't necessarily mean your eighth term. It means your ninth term. But other than that, it's actually relatively straightforward. Maybe your R can be a little bit confusing. 80%, remembering that that's 0.8, and then over here 60%, remembering that that's a 0.6. So anyways, that is it for this video. I think after this we're doing sums. So let me just zoom this out. We're going to go back to series.